Today we are going to see the AC applied across a capacitor. तो ये capacitor concept already आपने electrostatic में देखा है. So in electrostatic you have seen the capacitor, and for that capacitor we have seen the equation that is charge deposited on a plate of a capacitor is directly proportional to the potential. And this Q can be written as which is equal to C into V, where C is called as a capacity of a capacitor, Q is nothing but the charge deposited, and V is nothing but the potential developed. So that capacitor we are going to apply across AC voltage, and that AC voltage magnitude is nothing but E is equal to E0 sin omega t. In that E0 is nothing but the peak EMF. Now when across capacitor your AC is applied, it will send the current, that is nothing but the alternating current, and this alternating current will charge your capacitor. Clear? So that alternating current I can write down as a dq by dt. Is it right? Current I is nothing but your dq by dt. That is rate of flow of charge with respect to time. Okay. Now from this, now we are going to find out the value of current which will be going to be charged your plate of the capacitor. So in that, now I am going to substitute here I is equal to ddt of your Q value in case of capacitor. Q is equal to CV. So I am going to write down here as a CV. Now V is nothing but the potential developed across the capacitor. So this potential developed across capacitor is nothing but equal to the EMF which is applied across the capacitor, and your EMF applied across the capacitor is nothing but your E is equal to E0 sin omega t. So that value of V, instead of this value of V, I can write down I is equal to ddt of in bracket C into E, where meaning of E is nothing but your alternating EMF. So that I am going to write down I is equal to ddt of in bracket C, instead of E I can write down E0 sin omega t. Clear? Now here we have to find out the derivative of term C E0 sin omega t. Now in that derivative your C and E0 are the constant quantities, because C is nothing but your capacity of the capacitor, E0 is nothing but the peak EMF of alternating EMF. Therefore this C E0, these are the constant quantity, so I will take out of derivative, and now I am going to find out derivative of sin omega t. So this is nothing but my value of I. Now along in mathematics you have seen the derivative of sine term, and derivative of sine term can be written as I is equal to C E0 ddt of sin omega t. ddt of sin omega t is nothing but cos omega t into omega. Omega is nothing but the derivative of omega t. Means now this term I can write down as a E0 omega c cos of omega t, which is nothing but as your I. Now in that your cos omega t, again I repeat here, derivative of sin omega t is nothing but cos omega t. So here I write down this omega t का derivative है आपका omega, so this omega term I will take it along with your constant term. So here I am getting E0 omega c cos omega t, that is nothing but the current. Now instead of this sin cos omega t, now I am going to use the trigonometry identity. Your trigonometry identity is sin of pi by 2 plus omega t can be written as a cos omega t. This is nothing but the mathematics identity. So using that mathematics identity, in the place of cos omega t, I can put the value sine of pi by 2 plus omega t. So I get it here, current I is equal to P0 omega c into bracket sine of omega t plus pi by 2. So this is nothing but my value of alternating current which will use to charge your capacitor. So this is your current value. Now that current value I can write down here. So alternating current value I is equal to E0 omega c sine of omega t plus pi by 2. So this is nothing but your alternating current. Clear? Now, here this current equation I can write down. I is equal to, instead of this E0 omega c, here I can put the term which is equal to nothing but the peak alternating current. That is small I0 sine of omega t plus pi by 2. And here I can say that I is the alternating current, I0 is the peak alternating current into sine of omega t plus pi by 2. So that value here I can write down. So instead of this E0 omega c, I can put it as a I0. And now if you compare your equation of EMF applied across a capacitor circuit and current flowing through that capacitor, if you compare these two equations, so in the EMF equation, your term is E is equal to E0 sine omega t, and the current through that capacitor I is equal to I0 sine omega t plus pi by 2. Means there is a difference between EMF equation and current equation. And that difference is in the phase angle. In the EMF equation, phase angle is omega t, and in the current equation, your phase angle is nothing but omega t plus pi by 2. So in current equation, your phase angle becomes omega t plus pi by 2. So omega t plus pi by 2 means what? In capacitive circuit, whenever it is applied across AC, the current will be in the leading stage. So I can write down here, in capacitive circuit applied across AC, current I leads the EMF by angle pi by 2. Or I can say that here in the reverse manner, the reverse thing I can write down that your EMF lags behind, E lags behind the current by pi by 2. Clear? Why? Because in the EMF equation, your phase angle is omega t, and in the current equation, your phase angle is omega t plus pi by 2. So your current is ahead by which angle? Pi by 2. That's why it is to be said that current leads the EMF by angle pi by 2 when capacitor is applied across the AC circuit. Clear? So here your question is there. What that question is for 3 marks? Show that current leads the EMF by angle pi by 2 when capacitor is connected across AC circuit. Clear? So this is your 3-mark question. So in that 3-mark question, you have to start from your original circuit. In that circuit, what amount of current is flowing? Then use the current definition. Current I is equal to dq by dt. In place of q, we can place your value of q which is equal to C into V, that is from your electrostatic chapter, and the concept is charge stored in the capacitor. So put that value of Q as a CV. Instead of V, now here EMF applied is E, so V is replaced by E. Then value of E is E0 sine omega t. Then derivative of sine omega t. So derivative of sine omega t is cos omega t into omega. Therefore, I am getting alternating current, which is equal to E0 omega c cos omega t. Cos omega t can be replaced by your mathematical identity, that is sine pi by 2 plus omega t can be written as a cos omega t. So in the place of cos omega t, I can put a value as a sine omega t plus pi by 2. And then instead of all these constant quantities, E0 omega c, I have kept the value as a I0. And then my current I am getting, current I is equal to I0 sine omega t plus pi by 2. And then I am going to compare the equation of EMF and equation of current. And whenever I am comparing that both the equation, then it is to be found that is your current is leading by angle pi by 2 than that of the EMF. Clear? So this is your answer of your equation question. Show that in capacitive circuit applied across AC, current leads the EMF by pi by 2. Clear? Now, the second point. What is that second point? Here I have done the replacement of I0. I have kept value of I0, which is nothing but E0 omega c. So I will write same equation here, E0 upon I0. So E0 upon I0 can be written as 1 upon omega c. And omega is nothing but the angular frequency. So in air standard we have seen the value of omega is equal to nothing but 2 pi. Therefore here I can write down it is equal to 1 upon value of omega is 2 pi f is the value of omega into c. This is nothing but your ratio of E0 upon I0. And this ratio E0 upon I0 is called as a resistance offered by the capacitor. And resistance offered by the capacitor is called as XC, where XC is nothing but your capacitive reactance. So now here I am getting value of capacitive reactance. Capacitive reactance. This capacitive reactance means the resistance offered by the capacitor, which is Xc. This Xc has a first formula E0 upon I0. Second formula 1 upon omega c. Third formula 1 upon 2 pi f into c. Means I can say that capacitive reactance is inversely proportional to frequency. It is inversely proportional to the capacitor. And if I am going to plot a graph of Xc and frequency, then the nature of a graph is an exponential decrease. Why? Because your capacitive reactance is inversely proportional to the frequency. Inversely proportional means as your frequency will goes on increasing, your capacitive reactance will goes on decreasing. In case of AC. Got it? But if I am going to apply a DC voltage, so in the DC circuit, frequency is equal to 0. Because in DC we are getting a constant voltage. Constant voltage means there is no change in frequency. No change in frequency means in DC circuit frequency is 0. So in DC circuit Xc is equal to 0. So in the DC circuit The resistance offered by the capacitor is 0. Therefore, capacitor always blocks AC, but it allows the flow of DC current. And as it allows the flow of DC current, this capacitor is used in the filter circuit. Now, where these filter circuits are used? These filter circuits are used in the power supply to filter out your DC current. And why it is used as a filter? Because for DC voltage source, your capacitor will offer zero resistance. It will allow all DC current to be get clear. So this is nothing but about your capacitive reactance. Fine. Now, using your current equation and your EMF equation for capacitive circuit. For capacitive circuit, your EMF equation is E is equal to E0 sin omega t, and your current is equal to nothing but current I is equal to nothing but I0 sin omega t plus pi by 2. So, if I plot a graph of EMF and alternating current with varying value of your omega t, so your omega t value starts from 0, pi by 2, pi, 3 pi by 2 and 2 pi. I will formulate the table. First omega t is 0. So your EMF, E is equal to E0 sin omega t. Sin of 0 is 0, तो your EMF आ जाएगा आपका 0. लेकिन आपका करंट इक्वेशन क्या है? करंट इज I is equal to I0 sin omega t plus pi by 2. आपका ओमेगा टी वैल्यू 0, so 0 plus pi by 2 means आएगा sin pi by 2, and sin pi by 2 is always 1, means for 0 omega t I am getting alternating current as a IC. Next value, next is what? Pi by 2. ओमेगा टी वैल्यू इज pi by 2, तो आपका EMF बन जाएगा E0, लेकिन करंट इक्वेशन में करंट क्या होगा? sin of pi by 2 plus pi by 2 means वो आ जाएगा sin pi. Is it right? And sin phi is nothing but 0. Next, pi. EMF में आ जाएगा E is equal to E0 sin phi. So sin phi means EMF आ जाएगा आपका 0. And current equation में क्या होगा? Pi plus pi by 2. So pi plus pi by 2 means वो आ जाएगा sin 3 pi by 2 by 2. So 3 pi by 2 which is equal to minus 1. तो यहाँ पे आपका करंट बन जाएगा ये माइनस I0. बाद में यहाँ पे EMF में 3 pi by 2, तो वहां पे आपका EMF आ जाएगा माइनस E0. करंट इक्वेशन में 3 pi by 2 plus pi by 2 means sin 2 pi हो गया. Sin 2 pi is 0. Now last value pi. Here your EMF will become 0 and your current will become maximum. That is I0. क्यों? क्योंकि करंट इक्वेशन में क्या हो जाएगा? साइन ऑफ 2 पाई प्लस पाई बाय 2 which is equal to sin pi by 2, and sin pi by 2 is 1, so your current will become IC. And now using that value, if I am going to plot a graph here, so in that graph I can plot a graph of angle. Your angle values are 0, pi by 2, pi, 3 pi by 2 and 2 pi. Just remember, whenever you are plotting a graph, ये जो angle वाले points plot कर रहे हैं, that angle point should be at equidistance. Clear? Now I am going to plot for EMF first. आपका highest EMF है plus E0, lowest EMF है minus E0. तो EMF का पहले देखेंगे. For EMF omega t 0, आपका EMF 0. Then pi by 2 के लिए आपका EMF है maximum. Then pi के लिए 0, 3 pi by 2 के लिए minus E0 and 2 pi के लिए 0. So I am going to draw a curve for EMF across capacitor in this manner. That is a sine wave. Now current का देखेंगे. Now what is the current for 0? Current maximum value क्या है आपका? Current maximum value is here. Current maximum value is positive I0. Minimum value is minus I0. And now, sorry, small I0, not capital. तो now, अभी इसके पॉइंट प्लॉट करेंगे हम लोग। ओमेगा टी जब 0 है तो आपका करंट क्या है? मैक्सिमम। पाई बाय 2 के टाइम आपका करंट है 0, पाई के टाइम आपका करंट है निगेटिव, देन पी पाई बाय 2 के टाइम करंट है आपका 0 एंड फॉर 2 पाई के लिए आपका करंट है वापस 4। तो यहाँ पे आपका करंट का इस टाइप में है। तो इफ यू सी हियर फॉर 0 एंगल, फॉर 0 ओमेगा 2 आपका ईएमएफ 0 है लेकिन आपका करंट मैक्सिमम। So what it shows, that is your current always leads, current आगे है, current always leads the EMF by angle upward. Clear? So this is about your capacitive circuit applied across an AC. Fine. Now in this circuit, now I am going to give the important points. आपको important points देने होंगे। Now what that important points I can show here, जैसे मैंने आपको इसमें दिया था, that is for inductive circuit I have given the consideration। मैंने आपको एक important बात बताई थी, क्या था? That is पहले हमने EMF की बात की थी, फिर करंट की थी। So what I'll say here, I'll say that first point is nothing but the EMF applied across capacitive circuit, which is E is equal to E0 sin omega t. Second point, current across capacitor, I is equal to I0 sin omega t plus pi. Is it right? Then the third point, that is from this EMF and current equation, I can say that across capacitive current, across capacitive circuit applied across AC, current leads the EMF by pi by 2, or EMF lags behind the current by pi by 2. This statement is very, very important for your MCQ question as well as for very short answer. So you have to underline that point very well. Clear? Then the fourth point is about capacitive reactance. Capacitive reactance formula. Here you have a numerical problem on this. So capacitive reactance is defined as resistance offered by the capacitor when capacitor is applied across AC. That capacitive reactance is denoted by XC, which is equal to 1 upon omega C, which is equal to 1 upon 2 pi FC. Therefore, I can say that capacitive reactance is inversely proportional to
जीतने के लिए किधर लेके जाते हैं क्या गंभीर में
capacitance. So here I can say that if I plot a graph of reactance and frequency, then the nature of that graph is the exponential. And whenever I am going to say that capacitor is applied across a DC circuit, at that time circuit frequency is zero. So if your frequency is low, your XC formula becomes 1 upon 0. So your XC will become as your impedance. So for DC circuit, the capacitive reactance is infinity. Capacitive reactance is infinity means it will block DC. And whenever it is blocking the DC, then it will act as a open circuit. And it will passes your AC circuit, AC current, AC component, but it will block the DC. And the last point is nothing but the graphical presentation. Sometimes एक मार्क के लिए आपको ये graphical presentation आ सकता है, तो इसीलिए आपको बुक में टेबल नहीं दिया है. That's why I have given this table. So table, from that table you have to plot a graph. Graph plot करते time you have to remember the thing that आपका A0 वैल्यू ज्यादा है, I0 वैल्यू कम है, तो वो पॉइंट्स थोड़ा डिस्टेंस का ध्यान रखें. प्लस E0 माइनस E0 इक्विडिस्टेंस आना चाहिए, प्लस I0 माइनस I0 ओरिजिन से इक्विडिस्टेंस आना चाहिए। एंड ये जो एंगल्स है बीच के along the axis omega t, that is x axis, all angles should be equidistant, and then you have to plot a graph. So this is nothing but your graphical representation. तो यहाँ पे आपका ये ग्राफ वाला पॉइंट पे ये DC सर्किट वाला पॉइंट 6 graphical presentation is clear. So this is nothing but your AC applied across a capacitive circuit. Fine. Now what I am saying here, जो आपने इंडक्टिव में देखा था XL, so in inductive circuit we have seen XL. So in that XL, which is nothing but the inductive reactance, that which is nothing but your omega L. So that omega L is nothing but your 2 pi FL. And यहाँ पे आपका capacitive reactance is XC, which is equal to 1/2 pi FC. Fine. तो आपका एक नया क्वेश्चन आ सकता है वहां पे, डिस्टिंग्विश बिटवीन कैपेसिटिव रिएक्टेंस एंड इंडक्टिव रिएक्टेंस। तो उसका डिस्टिंग्विश हम लोग कैसे कर सकते हैं? इन शॉर्ट आई कैन राइट डाउन योर फॉर्म टू बोथ। सो योर क्वेश्चन इज distinguish between inductive reactance and capacitive reactance, that is XL and XC. The first point is nothing but definition. XL is what? Resistance offered by the inductor when it is applied across AC. Then XC is the resistance offered by the capacitive circuit when it is applied across AC circuit. That is definition. Second point, formula.